All right, welcome back to Unit Circle Round 2. I want to look at some of the questions on this worksheet a little bit and kind of try and clarify. They're not really doing a ton with a unit circle here. It's nothing crazy, but it's still relevant. So the other thing I want to point out real quick, last time we looked at the fact that on the unit circle, we've got our circle like so, that the coordinates of any point on here at any general point, as long as the unit circle is a radius of 1, are equal to cosine of theta, comma, sine of theta, right? And I want to actually add some concrete points to that now. So we can do that by kind of splitting things up a little bit. If this is a radius 1, then we know the coordinates of some points on here. For example, this is 1, 0. This is negative 1, 0. This is 0, 1 up at the top. And this is what? 0, negative 1 down at the bottom. And if you were enterprising a little bit, I don't think it's really covered much on these worksheets looking at them. Yeah, they really only do... Oh, no, they got some stupid ones on there, don't they? They got a 45 and a 120. That's silly. Yeah, well, that's fine, whatever, screw it. So the idea here is that we can subdivide and use some special right triangles to figure out some of the other details. So for example, if I cut this directly at a 45-degree angle, cut that right here, we'll say this is 45 degrees. If I build a right triangle around that, well, I actually know some special properties about 45-degree right triangles. All right, if this is 45 degrees, and that is 1, and then I can do some Pythagorean theorem work here, and you kind of figure this thing on out. So we know that since this is 45, the 100 degrees in a triangle, that's 45, and therefore this side and this side have to be identical. A little bit of fancy work. Let's pick a friggin' letter, and we'll call them K, right? So this is K, and that's K. And I do Pythagorean theorem, I get K squared plus another K squared is equal to 1 squared, aka 2K squared equals 1. Well, I divide by 2 and I take a square root and I get K equals whatever the square root of 1/2 is. And that's a little bit yucky. It's what, 1 over the square root of 2, but square roots in the bottom are gross. So we rationalize and we multiply by the square root of 2 on top and the square root of 2 on bottom. What we end up with is that K is equal to root 2 divided by square root of 2 times the square root of 2 is the square root of 2 squared, which is just 2. So I get this, and that's for this and that. So by extrapolation there, we have this point has an x and a y coordinate of root 2 over 2. And if we do a little mixy-matchy there, we can figure out that the cosine of a 45-degree angle is the square root of 2 divided by 2. And the sine of a 45-degree angle is also equal to the square root of 2 divided by 2. And then once I have that, I can mix and match a little bit, right? I can copy and paste this over there, and it should be at the same spot, except the x-coordinate will be negative. So I get, let's see, what is this angle? 45, 90, another 45, that's 135. And I get negative root 2 over 2 and positive root 2 over 2. And I mirror that down here, in which case both coordinates are negative, and I get, what, negative 135 plus 45 is 180, and 45 is 225. I get negative root 2 over 2, comma, negative root 2 over 2. Cool. And one last time, I can copy and paste that over here. And I end up with the x-coordinate's positive and the y-coordinate is negative. So the x-coordinate is root 2 over 2, and the y-coordinate is negative root 2 over 2. All right, we're getting a little cluttered. I get that. But this allows me now to answer some questions like, for example, what the hell is that angle? 270 and another 40, 315. There we go. know, I can say, what is the cosine of 45 degrees? I look at 45 degrees right here. I look at my cosine as my x, and check it out. That's root 2 over 2. Okay, well, yeah, what is the sine of 225? Well, the sine is the y coordinate, and I look over at 225, I look at the y coordinate, it is negative root 2 over 2. And then they get fancy on you, right? They say, oh yeah, well, what is the secant of 315 degrees? And you got to think back to your definitions a little bit. Secant is the reciprocal of cosine, so that means this is 1 over the cosine of 315. So I look at my 315, cosine is x, root 2 over 2. It's 1 divided by that, aka the reciprocal. So that ends up being 2 over root 2. But we got square roots on the bottom, and that's bad news, right? Nobody likes that. So we got to put our little algebra Rubik's Cube here. And we do 2 over root 2 times root 2 over root 2, which is just 1. Right? We're just rationalizing the denominator. And what do we got? This is going to turn into a 2. But I already got a 2 up there. So this 2 and that 2 are going to cancel, and I actually just end up with the square root of 2. The only other curveball they can throw at you is like tangent. But tangent is sine over cosine, which is the same, right? So the tangent of any of these, depending upon like the signs, is going to be either 1 or a negative 1. This will be 1. These will be negative 1 because there's only one negative. And in here, the negatives will cancel out. It'll be positive 1 again. So there's that little intro on unit circle for multiples of 45. I'm going to do one more that's going to show you a little bit more about multiples of 30 because that's kind of the last thing we can fill in as needed here.